Hello and welcome back to Geometry. Today we will cover Section 2.2, Logic, and complete the guided notes. More properly, this should probably be called Formal Logic, as I'm sure most of you are familiar with many of the concepts we're going to talk about in this section, but you haven't perhaps put them into quite the same level of rigor as we will see here. So let's start by looking at what we will learn. We'll skim the examples for Section 2.2 and predict two things that we'll learn about logic here. So let's see, awful lot of vocabulary right off the bat. We'll get to that up next. Example 1 says truth values of conjunctions, whatever that is. Example 2 says truth values of disjunctions. Again, we're not sure what these terms mean, but both said truth values of something. Here's a little summary. Negation, conjunction, disjunction. They're all under this category statements. So we could probably summarize those two things as finding truth values of statements. And then we'll have different types of statements to determine the truth of. Okay, that makes sense. We could even put them in a table, I guess. And then Venn diagrams, okay. Real-world use of Venn diagrams for organizing your information there. And that was it. So I think this last one was truth tables and Venn diagrams. So let's combine those two, talk about organizing information. Organize information with truth tables and Venn diagrams. Okay, and then take a look at our vocabulary activity here. We're going to be matching terms to their correct definition by drawing a line between the two. So it is not the case necessarily that truth table means sentence that's either true or false. We're going to have to remap these to their definitions as we read. So let's return to the beginning of the section. Determine truth values. A statement is a sentence that is either true or false. So notice right away we're talking very specific definitions here. This is not just English terms being applied here. A statement is a specific type of sentence, one that is either true or false. If you can't assign a truthness or a falseness to your sentence, then it wasn't a mathematical statement. And that's going to happen quite a bit in this section in particular and throughout this chapter as we go. Very particular definitions here for things you were probably already vaguely familiar with. The truth value of a statement is either true or false. So just like variables can have values that are numbers, truth values would just be trueness or falseness. Statements are often represented using a letter such as P or Q. So statement P, a rectangle is a quadrilateral. It has a truth value, true. That statement is true. Rectangles are quadrilaterals. And we're going to do so many more things with that entire sentence. It's going to get really tiring to write it over and over again. So we take a shortcut and say, at the very beginning of the problem, this sentence is going to be shortened to the letter P. Okay, so that gives us a couple of vocabulary terms here. We have statement, is a sentence that is either true or false. So we will connect statement to a sentence true or false there. Truth value is just true or false. Truth value of a statement as either true. Oh, it's right there. Alrighty, that one was easy. What else we have? The negation of a statement has the opposite meaning as well as an opposite truth value. For example, the negation of the statement above is not P, or squiggle P, tilde P. We would just read that not P. Not P is now the statement, a rectangle is not a quadrilateral. Well, that's not true, so the truth value is false. Okay. Where do we have negation on here? There's negation. We need statement with opposite meaning. There it is. Opposite meaning. All right. Now what about compound? Two or more statements joined by the word and or form a compound statement. A compound statement using the word and is called a conjunction. A conjunction is true only when both statements that form it are true. So we have first statement, a rectangle is a quadrilateral. New statement, a rectangle is convex. So we could combine them, P and Q. A rectangle is a quadrilateral and a rectangle is convex. That's true. Since both P and Q are true, the conjunction P and Q, also written P caret Q, is true. Okay. P and Q, also written P and Q. We've got this very sharp caret here, but it's up and around, pointed that way. It's upside down V. Kind of looks like a very spiky N, means and. So it's when you want both things. And real quick, on to the next one. A compound statement that uses the word or is called a disjunction. So Malik studies geometry. Malik studies chemistry. P or Q would say Malik studies geometry or Malik studies chemistry. Now, could both of those be true, depending on how broad you're talking about? Sure, but if you're talking about only during third period, well, you can only have one class at a time, so maybe either one or the other is true. A disjunction is true if at least one of the statements is true. Okay. If Malik studies either geometry or chemistry or both, okay, so we could also do both. The disjunction P or Q, also written as PVQ, no, P or Q, is true. If Malik studies neither geometry nor chemistry, P or Q is false. Okay, P or Q written as P, V symbol Q. So that gives us disjunction or. All right, let's return to our vocab here. Disjunction, two or more statements joined by and or. Well, that's either of them, so that's both of them are types of compound statements. So let's connect that down here. Okay, and you know what? I don't like how these lines are turning out. So I'm going to go kind of from the center, so they're not all going on top of each other. I'm going to run out of space in the middle here. And then this one can go from compound statement up to there. Yeah, it runs through some of the other words, but I think it's a little more clear what's getting connected here. Okay, and then we need, here is or. That one was disjunction, so disjunction is going to connect over here. And then down here I see and, so that would be conjunction right nearby. Okay. And is that everything? That's everything but truth table. Okay, let's keep reading. And here is a great concept summary here of the three different additional types of statements. The original statement itself, and then you can make a negation, you can make a conjunction, and make a disjunction. A convenient method for organizing the truth values of statements is to use a truth table. Truth tables can be used to determine truth values of negations and compound statements. Okay. So this is just a visual way of tracking all the possible combinations. So notice with the original statement, for the negation, the statement can be true, and then its negation is false. Or the statement could be false, and then the negation is true. A conjunction combines these two together with and says when both of them are true, I need both of them to be true for the whole conjunction to be true. If only one statement is true, P is true, but Q is false, well then the conjunction is false. I don't have and, I don't have both. And likewise, if P is false, but Q is the one that's true, that's still only one, that's no good, the conjunction is false. And then if P and Q are both false, well then clearly the whole thing is false. So I only get truth when both of them are true. Contrast that to disjunction, it's an or, P or Q. So if I have both of them, that's great, that's more than I needed, but that'll still work. If P is true, but Q is false, well, P is true, that's one, that's all I needed. This P or Q, I will take either one equally, so the whole thing is true. P is false, Q is true, that means I have one is true, so P or Q is true. In this case, it was Q. But if P is false and Q is false, I didn't get anything true here. P or Q, you got neither, so the whole thing is false. All right, so then let's add truth table to our list. I think right down here is the only statement not used. Convenient method to determine the truth value of statements. I have to zoom out just a little bit. It's a big line. There we go. And let's see, what does it say here? You can use truth values for negation, conjunction, and disjunction to construct truth tables for more complex compound statements. Ooh. Such as, example 3 will have not P or Q. We'll take a look at that one in part 2 when we do the examples. If you wanted to summarize the truth tables, notice that the conjunction, that's and here, is true only when both statements are true. They've highlighted that in red. And the disjunction is false only when both statements are false. That's what they've highlighted there as well. Okay, how about Venn diagrams? Conjunctions can be illustrated with Venn diagrams. Consider the conjunction given at the beginning of the lesson. P and Q, a rectangle is a quadrilateral, and a rectangle is convex. It kind of sounds like we're talking about categories here. There's this thing called a rectangle, a category that is quadrilaterals, and you can put the rectangle in the category of quadrilateral. So you could represent that visually with the Venn diagram. The Venn diagram shows that a rectangle, R, is located in the intersection of the set of quadrilaterals and the set of convex polygons. So they've made a group here called quadrilaterals a group here called convex things, and the rectangle sits inside both circles at the same time. In other words, rectangles must be in the set containing quadrilaterals and in the set of convex polygons. Yes. Everyday use, the point at which two or more objects vocabulary is intersection is what we're describing here. So we say two or more objects overlap. Math use, the intersection of two sets. Then, so a group of things is the group of things, the set of elements that are common to both. What do both groups have in common? Both groups have rectangle in common. A disjunction can also be illustrated with a Venn diagram. Really? Consider the following statements. Okay. P says a figure is a quadrilateral. Q says a figure is convex. P or Q says a figure is quadrilateral or convex. So in the Venn diagram, the disjunction is represented by the union of two sets. Oh, this is different. The union includes all polygons that are quadrilaterals, convex, or both. Okay, so here is the three regions here. Hold on. Quadrilaterals is this circle. Convex is this circle. They do overlap, and once again we have P and Q in the middle. And then look at how they've labeled the other one. This is P and not Q. Quadrilaterals that are not convex, because it's in this circle, but it's not in that one. Okay. Not P and Q, convex polygons that are not quadrilaterals over here, and only over here, not in the middle. And then P and Q, the middle, polygons that are both quadrilaterals and convex. And then the whole double circle shape here is labeled P or Q. So it's the union of them, right? Combine them together. The joining of two or more objects. The union of two sets is the set of elements that appears in either of the sets. So a little sub-vocabulary there that we won't be going too heavily on, but good to understand as well. And there will be a real-world example using the Venn diagram there in part 2. And that is the end of the text. So let's take a look at the vocabulary link down here. Negation is a word used in everyday English as well as in mathematics. Look up negation in the dictionary. Explain how the English definition can help you remember how negation is used in math. Okay. Let's look up negation. Come on. There we go. Negation. Ooh, the act of denying. Denial. Something that is without existence, non-entity. Okay, that seems a little harsh. The act of denying. Somehow my stylus is not registering anymore. What's going on? There we go. Negation. Act of denial. Okay. So if you deny the statement, it is negated. Right? I say that rectangles are quadrilateral. I deny that. I deny. No, it's not true. Okay, then the statement is false. It's the opposite. It's negation. Doesn't mean you're correct, but that would be the negation of the statement. Okay. Seriously, how does my stylus tip suddenly not work anymore? But this side does. I'll have to figure that out later. Fill in the blanks to summarize negations, conjunctions, and disjunctions. Write a description of each term. Okay, so we can take a statement, and we can take its negation, and we can combine them to make conjunctions and disjunctions. There's more bubbles than that. What else we got? Conjunction, negation. Oh, compounds. Oh, of course. From a statement, you can make compound statements. Okay, and it said describe them, so more than one. Negation, not. And compound statements can be either conjunction and, or disjunction, which is or. And what else? There's some other term we can throw in here. Apparently, I guess I don't need the textbook now. Okay. Truth table? No, truth value. Yeah, truth value. You can determine the truth value of a statement. So we'll put that in there. Truth value, T or F. And now let's try a Venn diagram. Model the situation with a Venn diagram. At Terrace Middle School, 68 students play basketball, 77 play volleyball, 19 play soccer and basketball, 27 play all three sports. If 13 students play both volleyball and basketball, how many students play just basketball? Oh, okay. So let's model. I don't think we really have anybody that's none, but we'll say here we'll have all. This will be students playing sports. Which sports? We'll have basketball, volleyball, and what's the other one? Soccer. Okay, 68 students play basketball. Okay, don't put 68 here because you also have these three that need to contribute. 77 play volleyball. I think we want to start with the intersections, would be easier. 19 play soccer and basketball. So soccer and basketball, that intersection is definitely 90. No, wait. "13 students play, 27 play all three sports." So 27, there is it. That would include the 19? Oh gosh, okay, so there's 9. So this group is actually 19 that play soccer and basketball, but 27 play all three. Well, that's not possible. I can't have the larger group be smaller. So I'm going to have to assume that they mean just soccer and basketball. 13 play volleyball and basketball, and that's 13 there. How many students play just basketball? Well, it's not going to be the 68. We want to know how many students here such that B plus the 13 plus the 27 plus the 19 equals 68, right? 77 play volleyball. That doesn't really help me. I could put 77 here, or we could say all of this is supposed to be 77. I don't know the overlap between volleyball and soccer specifically. That I don't even know how many total students there are, but I'm just trying to find basketball. So we're not able to actually complete this Venn diagram. That does bother me a little bit. But I can find the number that just play basketball. So 13 plus 27 is 40 plus 19 is 59. So B plus 59 equals 68. Subtract 59 from both sides. That's almost 60. Minus 60 would leave 8. Subtract off one more. We get 9. So 9 students play exclusively basketball. All right. Helping you remember. Yes, we want help with this. Prefixes can often help you remember the meaning of words or distinguish between similar words. Use your dictionary to find the meaning of the prefixes con and dis, and explain how these meanings can help you remember the differences between conjunction and disjunction. All right, con we've already seen before as in collinear and coplanar, con with or together. What about dis? Can we look up prefixes on this dictionary? Let's find out. Dis. D's. What? Okay. Apparently that's some Scandinavian term. Or God, the Disney Channel? Latin prefix, there we go. Apart, asunder, away. Torn asunder. Okay, apart or away. Okay. Apart. Away. So conjunction brings together, while disjunction keeps apart, keeps them separated, right? They don't get combined. Conjunction combines them, brings them together with the word and. Disjunction keeps them apart, separated, or this or that. Okay, I like that. That will conclude notes for section 2.2. Come back for part 2 to complete the 4 examples from the book. So long, farewell. Enjoy the rest of your day.